Whoa, whoa, whoa! Heard you need an answer key, so let's see if I can make one in approximately 12 minutes before going out to dinner with my stats friends in New York City. Gonna have a little Italian. So I better get started. Sorry you can't see the question on the screen, but question number 1 on the quiz review is about p equals 1/12 as a null hypothesis. P is greater than 1/12. I should probably read the question, but I don't have time. So what was the sample? The sample was 600 students. 600 students is the sample. The statistic observed is p hat equals 59 over 600, which is roughly this number. All right, moving right along. Check that the conditions for inference have been met. Well, let's see. We have random sample, numero uno, random sample of 600 students, and that was a random order that they were shown the whatever it is. Number 2, to check is the p-hat distribution roughly normal, we need to check 600 not times p-hat, but times the null hypothesis value, which I have a calculator here, and let me just crunch those numbers. 50. That's greater than or equal to 10. And 600 times the complement of that 1/12 is this. That would be 550 is greater than or equal to 10. Also, thirdly, we can assume that there are more than 6,000, 600 times 10, students or, college students that you could pick. That was answer number 2. Numero 3, calculate the standardized test statistic. Let's go. Oh, erase. Calculate the standardized test statistic. That would be this formula, z equals, what is this, number 3? Z equals p hat minus the null hypothesis p over the square root of, make sure you use the p null hypothesis value in the denominator over n. So this would be the 0.0983 minus the 1/12, whatever that is, as a decimal, over the square root of 1/12, 11/12 over 600. So the standardized test statistic is 0.0983 minus 1/12. That's the numerator, divided by the square root of 1/12 times 11/12 divided by 600. I hope the order of operations is okay because I didn't use parentheses. You get this standardized test statistic. What that's giving you is, on a standard normal curve where the center is 0 and the standard deviation is 1, that's giving us a value right about here. And we want to know from the direction of our alternative hypothesis how likely is getting this value or more, it's a greater than, just by random chance. So to get a p-value using table A, you would be looking up this value on table A. You got to do a complement. So we get something like roughly a p-value of probability that z is greater than 1.326 equals 0.0924. That's our p-value. We talked about when I was there p-values. Interpret the p-value in context. So this would be assuming this value, assuming that the order that they're shown, the whatever it is, that they're shown those, that the order doesn't matter. There's a 9% chance, 9% probability that they would get a test statistic as large as 1.326, or that they would observe a sample proportion as large as 0.0983 or more just by chance. That's the interpretation of the p-value. The conclusion we would make is, well, I think it said our alpha is, let me get rid of some of these keystrokes. I think they said our alpha is 5%. Our p-value is very large. I think it was a 9% sum. So we would say since 9% is greater than 5%, we don't reject, or we fail to reject the null hypothesis and don't have convincing evidence, that P is greater than 1/12, just whatever the context is. I didn't read the context because I was in a hurry. That's the first question. Maybe later, if I have time, I could do the second question, but I need to leave a little bit of time to see if I could post this on YouTube. All right, I think that's it. Have a wonderful day. Ooh, give him some hair.